Welcome to 4.2 in the journal, Reflections. This is page 99, goes up to 101. Remember, try to answer the questions before I say them. Use that pause button, get it down, see if you can answer it. Practice your thinking, always a good habit to be in. Plus, you get to look at me looking down up here, just trying this little picture in the picture thing here. Reflection, let's start with that one here. A transformation using a line like a mirror to, try to get it in there, pause it. Reflect, no big surprise there, a figure. Okay, the line of reflection, that's the mirror line, where that mirror would be reflecting it back and forth. Glide reflection, this is a composition. Remember, a composition means more than one transformation. So it's a composition of transformations. So you perform a translation or a glide transformation first. And this shouldn't be by, it should be then. Sorry about that. And you've probably figured it out by now. If it's a glide reflection, we got the glide in. You just need to do the reflection. Okay, so that's a glide first, then the reflection. Line symmetry. So we're on line symmetry here. When a figure can be mapped to itself by a reflection line. Okay. It's also like folding it onto itself like a sheet of paper. Like if you folded something onto itself so it mapped, the little fold in the line in the paper would be the reflection or the line of symmetry. The line of symmetry is our line of reflection in the line symmetry. Okay, so we don't use this a whole lot, and we don't use it on angled lines really at all, but just knowing what a reflection is. So here's your pre-image, here's your image, okay? Notice if I draw a line from P to P prime, it's perpendicular to my original line, and P and P prime are equidistant from that line, okay? So the line connecting them is perpendicular and they're equidistant from the line of reflection. We're going to have some other rules we use later in there. So these rules here, not a huge idea. If P is not on M, P is not on M, then M is the perpendicular bisector of P, P prime. That's what we had said before. It's got to be perpendicular, they got to be equidistant. If P is on M, then P equals P prime. That's what they're saying right here. If it's on the line of reflection, the image and the pre-image are the same. Also note here, some figures are going to overlap, some won't. You'll see that in some of the examples. Okay, these rules right here need to be memorized. You always have to have access to them. I mentioned here you may want to put them on a note card, keep them handy so you can use them. I simplified them a little bit here. This is our line of reflection. And the rule that goes with it. And we also mentioned here reflection is a rigid motion. You remember what a rigid motion state means? It means it doesn't change size or shape. Okay, let's get into our examples here. I have graphed some of these already. So I want to reflect this one around the y-axis. So here's my y-axis right here. So I mentioned on this one, I can use concept or the rule. Okay? So I'm going to show using the concept. I'll show using the rule down here. Maybe show a little bit up here. So I notice, okay, here's my little line that's running perpendicular to my line of reflection, the y-axis. I've got 2 units to the left here, so I go 2 units to the right here, and that's going to be my new point. And let me get rid of these. I look at this one. Whoops. It's 4 units to the left, so I've got to go 4 units to the right. That's going to put it right there, and I forgot to label my first point. That should have been A prime. This would be B prime. You could do the same for C. 3 to the left. You know, you've got this. I didn't draw it out, that little line there. I didn't draw it out on this one because you can kind of see the gray line there already. But that's going to be 3 to the right. There's our C prime. And there's our image. You know, you could have also used the rule here. So around the y-axis, that's the A changes. So that's AB. So that's AB into the opposite of AB. So I could have taken like point C. That's going to be -3, 1. That's going to go into our C prime. So I'm going to have the opposite of -3, and then the B stays the same. It was 1, it's 1 here. So that's going to be 3, 1 for C prime, and you can check that's the point we have over there. I always forget to say this. Make sure you look at the book. There's lots more examples and information in the book than is in this. This skips some stuff sometimes. Number 4, x equals -3. Well, I had to change my scale a little bit here. And I should also note I changed the scale in the first one. Notice I went 0, 2, 4, 6, 8, 0, 2, 4, 6, -8. You don't have to have the same scale on the x and y axes. On the x, I got -1, -2, -3, -4. I didn't really look at those. I already had them plotted. I'd forgotten about that. But I had to change it here too because it was going to go way, way off the graph. These graphs on these problems aren't real good. They should have been bigger. They're not very well thought up. So I got x equals -3. So I'm going to draw in my line of reflection here. So that's x equals -3. That's not x equals -3. You know, maybe I didn't need to do it on this one. I wasn't thinking really well here. So x equals -3. So that's going to be right there. I guess I did need that anyway. So x equals -3. That's my line right there. X equals -3. So I'm just going to look at this. I'm going to use that theory like I did on the first one. I forgot to label these points. Let me do that. Oh, I did. There's A, B, and I just didn't get the C on there. The B is just kind of hard to see. I moved the B a little bit. Just like I'm going to move this A up here. Okay. This is 1 to the right. I'm going to go 1 to the left over here. What color should I make this in? Let's do the green again. So that's going to be my B prime. C is 1, 2, 3. Because again, notice I got blocks of 2 on here. So that's going to be 1, 2, 3. There's going to be my C prime. A prime is 1 to the right. So there's my A prime. And we got it there. And you can see that those are mapped fairly well there. Over here, let's take a look at number 6. Y equals -x. Now to draw this out, remember, this is the same as this equation right here. Y equals -1x plus 0. Y-intercept 0, slope of -1. That's going to be, let's use the black here. It's going to make it right on these. And that's our line of reflection for this problem. Now the theory works really tough here. So this is around the y equals negative x. So that's this rule right here, opposite of b, opposite of a. So I'm going to write it out. AB goes into the opposite, opposite of b, opposite of a. Okay, get that back. So I messed up, had to do a correction here. So read my points bad. So notice again, you got these weird scales. So this means -2, -4, -6, 2, 4, 6, 8. Don't forget that. Whoops, erase too much. Let's get rid of these. Sorry, hate wasting the time like this. Okay, so I got point A. That's at 2, 0, because again, 2, 4, 6, 8. So when I go into my A prime, 0, opposite of 0, 0, opposite of A is -2. I'm going to plot that. So that's going to be 0, -2. That's going to be my A prime. I get my B coordinates down. B is 5, 3. Okay, so that's going to go to B prime. B is 3, so that's going to go opposite of 3, opposite of 5. So I have -3, -5, which is going to be right there. That's going to be my B prime. C is 2, 5. So again, C prime, -5, -2. Notice the A and B switch order and switch sign. So I got -5, -2. That's going to be right there. That's my C prime. And D, what do I have here for D is 1, 4. So my D prime is going to be -4, -1. That goes right there. That's my D prime. I can connect that out. That doesn't look really good, because that should be a -1 up there. -4, -1. I went to +1. That looks a lot better there. Okay, notice I use my vision to check. Okay, we're running short on time. Got to go quick. Translation first on this glide reflection. X -6, X -1. Again, notice we got these weird scales on here, but I could still count out 2, 4, 6 left, 1 down. That's going to put me right there. That's going to be my L prime. Then I've got my y equals -x rule, and I could do that. So I got y equals -x. That's A, B goes into opposite of B, opposite of A. We just did this one. I'm going to use my new coordinates here. That's going to be my L prime is -5, 2. And that's going to go into -2, 5. I forgot to put my L double prime. So that's going to be -2, 5. And that's going to be my L double prime. I could have used the rule up here for L2 if I wanted to. I could have taken the point for L. I could have said, oh, that's 1, 3, 1 - 6, and then 3 - 1. That gives me -5, 2, which you can see I had in this coordinate right here. You can go through and do those the rest of the way. Lines of reflection here. Ooh, I got a line of reflection there, and I can map that over on myself. Do any of these other ones have lines of reflection? It can be like this, it can be like that. And this one, it's like pool, it's off the rail. It's wherever the reflection would go to the other computer. That's going to be your shortest line right there, is when, you know, that just reflection comes off there. That's about it. We're done here. This is going to end. Bye.